Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the GRE official guide, the 4th edition. If you do not own this book already, purchase one immediately. You're going to need it. Today is our lesson number 41. We are on page number 233, problem number 2 on page 233. On page 233 you will see only two problems, 1 and 2. We did problem number 1 yesterday. The problem that we did yesterday, number 1, was a very simple, very babyish problem. It was a gift. It was very simple. The problem that we are about to do will require some thinking, would require some work. So here we go. We are told that we have 95 measurements. 95 measurements were recorded. 95 observations were recorded. They were grouped into 7 different intervals. As you can see here, 1, 2, 3, 4, 5, 6, and 7. 1 through 5, 6 through 10, and so on and so forth. There are 7 intervals, equal intervals, 1 through 5, 1 through 5, 6 through 10, 11 through 15, 16 through 20, 21 through 25, 26 through 30, and finally 31 through 35. 7 intervals. This is the frequency distribution. We are told that frequency distribution is as shown. As you can see, in the first category, observation 1 through 5, any value that was either 1, 2, or 3, or 4, or 5, they were recorded. And there were 15 such observations. The value of 6 through 10, there were 35 such observations, as you can see here. There were 35 some other observations. Again, in the next category, 11 through 15, we have again 15 observations. Then we have 12 observations. Then we have 10 observations, then we have 5, and then a 3. The question is very simple. Very straightforward. Which one is bigger? Column A, mean, or column B, median? Go ahead, do your work. I'll give you a second to be able to, for you to be able to pause and unpause the video, do the work, and then after you finish doing your work, compare your work against the work that you and I will do together. So the question is, which one is bigger, mean or median? Is column A bigger, column A bigger? Are they equal, or we simply cannot tell which one is bigger, in which case the answer is D. I'll give you a second to be able to unpause and pause the video. Let's see what we can do. There are only two things we are dealing with: the mean and the median. And the median. Let's start with something simpler first. Let's start with median. Median, we have 95 observations. Therefore 94 divided by 2, we get a 4, carry 1, 14, that's 7. That means we have 47 observations on this side, 47 observations on this side, and the 48th is the median. The 48th observation is what we need to locate because that is our median. Let's see what we can do. Well, in the first category, 1 through observation of values of 1 through 5, we have 15 such observations, as you can see here. And then the next category, of observation of values of 6 through 10, we have 35 such observation. 35 such observation. Well, that's already 50. 15 plus 35 is 50. We're trying to look at 48. 48th observation is here. It's somewhere in this, somewhere in here. But because we are not given unique value of the observations, since we are given in the intervals 6 through 10, we can't really tell what exactly was the value of the 48th observation. Maybe out of the 35 observations, maybe 34 of those observations are 6, and the 35th observation is the value of 10, in which case the median 48th observation would be 6. Or maybe it's the other way around. Maybe all the observations are 10 and we have one observation of 6, in which case the median would be 10. Or maybe all 40, maybe all 35 observations, maybe all 35 observations in this category, they were all of the value of 7, in which case the median is 7. Or maybe they were all 8 or all 9. We really cannot tell what the median is. All we can tell with certainty is that the median, whatever it is either a 6 or a 7 or an 8 or a 9 or a 10. That's all we can tell with certainty. But there's not much we can do. There is not much more we can do here. Median is either a 6 or 7 or 8 or 9 or a 10. Let's look at the mean. Now, because we need the room here, I'm going to erase all of this thing because it's occupying a lot of room and we need this space. So we have 15 in the first category. We have 15 in the first category, 35 in the second category. We have another 15. Then we have 12. Then we have a 10. Then we have a 5. And then we have a 3. Let's erase all of this thing so that we have the room. And before we do anything, I just want to make sure that I did not make a mistake, that I did not mess it up somehow, that I did not miss something. I'm going to add them up very quickly to make sure that we do get 95. So here's the 5, 3 and a 2 is 5, 5 plus 5 is 10, 15, 20, 25, that's a 5, carry 2, and we get 2, 3, 6, 7, 8, 9, there we go, 95 observations. So that makes me feel much better. Now the question is, how are we going to figure out the mean? Again, the same problem is impossible. It is impossible to figure out the exact value of mean because we don't have the individual observations. All we can do is look at the extreme scenarios. Extreme scenarios being, can the mean be less than 6? Well, let's take a look. Can the mean be less than 6? There were 15 observations. 1 through 5. So let's put it right here. 15, 35, 15, 12, 10, 5, and 3. So we're looking at two extremes, the least possible value of mean and the greatest possible value of mean. If we can somehow show if we can somehow show that the greatest possible value of mean, or rather the least possible value of mean, is greater than the greatest possible value of the median, then we are in business. Similarly, if we can show that the highest possible value of mean here is still, the greatest possible value of mean here is still less than this guy, then we are still in business. We have to look at the two extremes. Let's look at the least possible value of mean first. Let's see what happens. So the least possible value of mean, what we're going to do here is that we have the category 1 through 5, 6 through 10, 11 through 15 and so forth. And we're looking at the least values. So the least value for the first category would be 1. These are the values. 1, these are the frequencies. For the next category, the least possible value would be 6, then the 11, then the 16, then the 21, then the 26, and then 31. Let's see what happens. Let's see what we can do, okay? I'm going to try to pick up the speed here because I'm taking too much time here. It just dawned on me. So, let's erase this thing so I can continue here. We don't need this anymore. Let's see what we can find. So 15 times 1 is 15. We need 35 times 6. 30 times 6 is 180. And 6 times 5 is 30. 15 times 11, 15 times 10 is 150. And then 15 times 1 will be 15. 12 times 6, 12 times 16, 12 times 16 times 10 is 160, and we need 2 more 16s, that's 32. 10 times 21, that's easy, that's 210. 25 times 26 times 10 is 260, so it is 130. And finally 3 times 31, I'm going to round it to 100, or if you like, maybe 95, or actually 93. It's not that complicated. Let's see what happens, shall we? The reason I changed my mind from 95 to exact value is because I just noticed a 2 here. 2 plus 3 is 5, 5 plus 5 is 10, that's a 15. Carry 1. Let's make sure we don't make any mistake. 1, 2, 10, 13, 14, 14 and 6 is 20, 25, 25, 28, 29, 29, 39, 38, 38 plus 2 is 38 plus 2 is 40. Carry 4, and the 4 is going to be in this category right here. 4 plus 1 is 5, 6, 7, 8, 9 and 10. I come up with 1005. It doesn't have to be accurate, it doesn't have to be exact. If you're off by a little bit, it's not a big deal, it's not the end of the world. Maybe I made a mistake somewhere else because in my notes it says 1015. Here I come up with 1005. That's okay. The point is this, even if the total is 1005, I just realized in order to make a dramatic gesture that I want to make, I need more room. Where can we do it? Even if it's 1005, since we have 95 observations, 1000 divided by 100 would have been 10. Since we have, first of all, we have 1005, and we have only 95 observations. This quantity, whatever it is more than 10. This quantity is more than 10. So here's what we established so far. What we established here is that the least possible value of mean, is greater than 10. But 10 also happens to be the greatest possible value of median. If the smallest possible value of mean, if the least possible value of mean, if we were able to show just now that the least possible value of mean is greater than the greatest possible value of median, because the median had to be either a 6 or a 7 or an 8 or a 9 or a 10. Mean is more than 10, we just showed it. Therefore mean is bigger. The answer is A. Mean is bigger, the least possible value of mean is greater than the greatest possible value of median. I'll see you tomorrow, okay? Bye now.